sources. Borislav, that was a mouthful, but can you please come to the stage and hold your talk?
Indeed it was.
Thank you.
Thank you all. Thank you for coming. As the host was quite right, it was a mouthful. I didn't realize that. I thought that the title would be a little bit abbreviated, but indeed the topic of today's talk will be what we believe, and I believe, is the largest scale of AI currently available. What's interesting about that is that ever since the dawn of the internet, early days of Google, it was always a mythical thing how big Google index was, Yahoo, everything. Now it is also what is innate knowledge of ChatGPT, how many answers can Google answer directly without blue links, with info boxes, etc., etc. So this mysticism has continued, and all the players are closely guarding their secrets, which personally I always felt that it was kind of silly and ridiculous. So that's why we set out to try to disclose and reveal what those numbers are. You are going to see them and hear about them in today's talk. Of course, I invite everybody, we welcome and invite everybody to jump in and tell us if they know any better numbers. We would really appreciate that. So, one other thing, when I say here best, I know best is obviously an interesting term. It is subjective because never in this business or in AI, it always has been subjective. The measure of quality, Google included. So the beauty is in the eye of the beholder, in our case of us. But I will give you some into the director's objective measures and reasons why we believe that we are, as in the United States people like to say, and we too, as good as anybody, and as big as anybody. Oops. Oh. Okay. Just a very brief intro on my bio, in case you care. I currently have two related AI startups. We'll be largely talking about Toyota Answers, but very quickly about Kagi 2. Previously, I was in search. I founded the distributed social search engine. Believe it or not, that search engine was intended to attack Google. I got money from VCs about that. It was a very, very interesting journey. Facebook bought the company and Google bought the patents, which I thought was really interesting. And actually, a whole bunch of kids from Belgrade moved to Palo Alto. But that was one really intriguing journey. Before that, I founded a vertical car search engine because I was always a car freak, including now. I was always obsessed about cars. This company is acquired by Room in 2021. Before that, I was a senior engineer at Intel, designing microprocessors and stuff. Before that, I was doing my PhD, and enough about that. Oops, sorry. So, let's get into it. The main proposition we keep hearing incessantly over and over again now, for I would say at least 2 years, is how incredibly expensive it is to train, and not just train, but run and operate these models. Starting with GPT-3, now it's GPT-4 with all its variants, 4.0, 0.1, etc. Now the rumors about GPT-5, whenever it may come, etc. And these numbers are truly incredible. It started really with GPT-3, which reportedly 2 years ago cost $5 million to train, just for a single training run. Basically 10,000 A100 class GPUs running for 6 weeks on the cloud, and that was kind of it. But now, reportedly, GPT-4 is 100 million to train, and GPT-5 is God knows what. And now it's openly being floated in the United States, in the Valley and elsewhere, that we need data centers of 500 megawatts and even 1,000 megawatts class, which is beyond absurd. 1,000 megawatts, this is 3 million NVIDIA cards. NVIDIA cannot make that many GPUs. So all this, in my opinion, and not just mine, but I always fervently believe this, All this is intended to create a perception, an alternate reality, that this is a very exclusive province of only a few. Only the biggest of the biggest megatech corporations, not even sovereign countries, can play aside from United States, China, and maybe European Union. And nobody else needs to apply. This includes, for instance, the largest universities in the world, Princeton, Harvard, all those guys. They're actually quite upset about this situation because they're openly complaining that now they don't have data, they cannot train their own model, etc., etc. But the whole point of what we are doing in today's talk is to say that this is complete nonsense. This is just a basically intimidation mirage intended to basically deflect competition and trying to intimidate them. It is very much possible to have this scale of data, the largest in the world, with orders of magnitude, in this case, about 3 fewer resources. Another thing is that as a very important, crucial side effect, direct result of this humongous and absurd cost, there is absolutely no chance of profitability for these companies, starting with OpenAI. OpenAI, they're private, so they don't need to disclose any of the information, financials, but the rumor is that they are now on track to generate annual revenue, gross revenue of over $3 billion per year, which sounds fantastic for a startup. They're really a startup still. But there is just a small caveat that they're actually, with all that, they're running over $5 billion operating loss. This is absolutely ridiculous. I mean, so there is no way that no mature company can run that, never mind startup. So basically, at this rate, if they don't change anything promptly, which they think that they can start increasing revenue, they go on basically a path to imminent bankruptcy, basically toward the end of next year. So this then brings us to the real question. What resources are really needed to create a world-class system of this humongous scale with tens of billions of best-in-class smart answers? And here is our answer. yotaanswers.com. It has been openly available on the web for, I think, close to 2 years now, though we significantly improved in the last 6 to 8 months. The progress has been quite amazing, together with the progress of the entire field. The crux and the core engine of the system is our system, our proprietary collection of 27 billion vectors. Just to be clear, we are not licensing this from anybody, we are not reusing, we are not licensing ChatGPT, nothing like that. This has been built completely by ourselves. And to our knowledge, and again, I would love to hear if anybody knows any different, this is the largest such collections of vectors in the world. So what these vectors enable us to do is, by foundational and basically based on principal methods such as nearest neighbor search, it enables us to give clear and concise smart answers to many, many, many questions. By the way, many more questions than 27 billion, because you can ask a single or similar question many different ways. And because of this really amazing and world-class scale, there are no hallucinations, because we know where the answer is coming from. We know the source. This is the key feature of the system. These are in this side picture of our result, one of the smart answers to a query. These are these green circles, which are references you can check. And then you can verify that there is no hallucination indeed. To our knowledge, the scale of the system is an order of magnitude bigger than ChatGPT. Nobody knows, starting with OpenAI, what their innate knowledge is. meaning that what they hallucinate, they can't because of the black box nature of the system. You can get an idea of that based on the training data set, which us and others do know about. But we think it is about an order of scale bigger in internal innate knowledge. And compared to Google, which now for close to 25 years has been the gold standard of the best answers anywhere, we are here comparing in terms of direct answers, what Google calls those info boxes. These are boxes on top of results when they're confident they can give you direct answers what you're asking, as opposed to giving you 10 blue links and ads. So this is what restricted to our knowledge, it is at that scale. Though Google is improving quite a bit on this respect, and so are we. Another great benefit is that because of the nature of the system, when our system returns this type of smart answer, we can tell you why it returned that. Because we know it returned not only from the references, but we know what we call smart frontier. Basically, these are the nearest vectors. And in the system, this is why system returned results it did. And we know the details of the ranking. So we know quite a bit, and we can tell you why it said so. As opposed to, again, the magical and complete black box nature of ChatGPT. One of the really interesting things, this is the first point, to me actually, I was always amazed because this is kind of fairly obvious, but I've never seen anybody mentioning this. All LLMs currently by nature are depth first, because they repeat the same process over and over again. You create a vector for the sequencing so far, and then you predict a single next token. Based on temperature, it doesn't have to be the most likely next token. It can be close to that, but that by definition is depth first. So in a system like that, it is very difficult and quite hard to do a breadth first search. Our system is from the ground up designed to do breadth first, because this is how it collects these vectors. And we think this is actually a foundation of and one of the key parts of our qualities, and why we think our answers are as good as we think they are. So I told you about the scale in terms of Google. That's more than the number of direct answers. Again, I invite everybody to, who knows otherwise, to tell us. We would love to hear about it. So now, just a little bit about the sister system we have built. This is actually predates Jota Answers. And this deals about the other major problem, the key problem of contemporary LLMs, which is reasoning. So this system is a system which comprises of 2 billion vectors of causes and effects of virtually everybody. And causes and effects are the basis of all intelligence, both human and artificial. And again, this is the largest such system in the world to our knowledge and to my knowledge. And when I say causes and effects, I mean everything. Law, medicine, technology, cooking, history, whatever you think of, anything which deals with cause and effect, which by the way is everything in our lives, is included in this system. And obviously, contemporary LLMs are quite painfully aware of their shortcomings in terms of reasoning. They keep saying that they are improving that, but I'm not sure they're actually doing much in that respect. So, for instance, improvement of 4.0 and so. And this is just an idea. So let's just, the key interface, current interface in this system is, it gives me what we call a smart essay, which is a kind of a smart essay or summary of what are causes and effects of something. But that is created out of little atoms or pieces, which we call the reasoning frontier, like this. And of course, there is a small language which is assembling all that. I didn't mention that, but you may be wondering already. Let me state that clearly. It is true that our system, both of them, have LLMs at the back end. But these LLMs are so much smaller. They are literally 3 orders of magnitude smaller. And that's why they are so much cheaper to run and operate. So we can train them and run them and fine-tune them ourselves on a single machine, as opposed to these ridiculous tens of thousands of cards and stuff like that. So in essence, we are using LLMs only for the final assembly and some basically a summary or restyling, if you will. So the basic, we are getting close to the end, and then we'll have some time for questions. Basic point which we have to impress about everybody here is that we absolutely believe this very strongly, and me included. Wasting now $100 million for a single training run is absolutely beyond absurd. That's ridiculous. Nobody should be doing such a thing, no matter how easy they have an access to money, or they think they have an easy access to money. And the solution, instead of doing that, is to have collections of world scale. We think this has to be in billions, ideally tens of billions, that can be used to power smartly ranked and carefully chosen collections such as ours. The key point, again, is that it is those collections of vectors that encapsulate knowledge and everything, and the final LLMs is for really styling and final assembly, so to speak. And basically, the final point of all that, which I'm trying to convey, is that scaling generative AI should be about completely opposite to what's going on now. It should be about democratizing smart AI by making it available to millions of business and users worldwide, using approaches such as ours, and complementary or similar to. And instead of trying to pretend it is just a elite province of selected few. And a very important side effect of this, which I think even OpenAI and others would love to hear. By doing this, obviously, we can return this whole show, which is now a bit crazy, on the path of a viable business, basically enabling profitability. And that includes not just profitable businesses, also enabling open source and other things which will now non-profits and other activities without burning inordinate amounts of money. That's basically it. I'm going to stop here. Or whoever would like to contact me, this is my contact. So now we have some time for questions.
Thank you, Boris. Thank you, Borislav, for this insightful talk. I'm going to go to the room. Does anyone have any questions for Borislav?
Yeah, I do. Yes.
Can we, just a second, we're going to get you a microphone.
Yeah, great. Just if you can repeat, in what context did you mention the breadth-first search? I missed that part.
So the idea is that if we focus on LLM doing depth-first search, then we can ask the question, how would we accomplish a breadth-first search in that respect? In essence, what we would like to do is we will say at each point that LLM is choosing next token, choose several choices and then start expanding from there. This cannot be done natively because it leads to combinatorial explosion. And in our system, it basically comes out for free, because when you select closest vectors in nearest neighbor search and rank them, what you typically get is basically sets of clusters, if you will, in which the closest representative of those clusters is one of those several ones you have chosen. Of course, it is true that you can do prompting in an LLM. You can give it a prompt. Try to give me the following answer as if we are doing breadth first or something, but that's quite kludgy, and I really never seen it quite working like that. It's really kind of hacking it. It goes counter to what the system is really doing.
Okay.
Yes.
Thank you. Over there.
So thank you for the presentation. So Are you using like open source LLM, or are you developing in-house LLMs? Or?
We are using open source, but on the other hand, the most of the technologies is completely in-house. Like it is not like we are taking there aren't really, even in open source technologies, where you can load tens of billions of vectors, you know. So nothing, basically you have to do it yourself. And we have done so, and actually we are quite pleased about that. There is a team of young, brilliant developers who have done a terrific and fantastic job doing that, you know. So the core engine which scales all this is built by us, you know. So we are smartly, obviously we are using Linux, Python, stuff like that, but it's not in the core. So ranking is proprietary, and it's not that we are against open source. We really appreciate it and use it, but on the other hand, we don't want to allow anybody, including starting with big businesses, to freeload. So right now the system is completely open and free. We might change this in the future by adding some kind of pro layer or something like that, but we would like to keep it as long as possible that way. So.
Okay, thank you for the question. Do we have any more for Borislav?
All right.
If not, I always like to repeat, Borislav will probably
I'll hang around. So.
He'll hang around, so if you think of something and catch him in the hallway, feel free to ask him. Borislav, thank you so much for the presentation.
Thank you.
And this is for you.
Oh, thank you.